Good afternoon, good evening, ladies and gentlemen. Welcome to a series of tutorials. I am here with Mr. Anga. I am Tutor Aubrey. Full name's Aubrey Undipiri. I will be your tutors for complex analysis and probability. All right, so today we are starting with complex analysis, and basically we are looking at complex integration. Complex integration. Okay, we're looking at complex integration. All right, so under complex integration, we have two types of integration that we need to look at. That is, we are supposed to start with line integrals, but for the purpose of this video, we are just going to start with contour integration. So, but basically we're supposed to start with line integration, then we go to contour integration. Then we do contour integration, but I was told that you started or you were doing contour integration in your previous contact session. So it fit that we do contour integration. Then if there are queries for line integrals, please remind us or tell us so that we do that one as well. So, but for this lesson, we are starting with contour integration. Now, under contour integration, we are supposed to learn two types or two methods of integration, or two methods that we can use to integrate. Okay, the first method that we are going to learn, which is this lesson, will be based on the residue theorem. Residue theorem. Okay, residue theorem. Then later we are going to do what? Cauchy's theorem. Cauchy's theorem. Cauchy's theorem. Right. Later we'll do Cauchy's theorem. So we are going to start with residue theorem. So in this lesson we're doing residue theorem. Okay, residue theorem. What does residue theorem state? Okay, the residue theorem says that so if f of z, or so if integral of f of z is undefined at z naught equals to c, okay, then it has a residue. It has a residue at c. At c has a residue at c, and so this is how we find the residue at c. So residue at c is given by the limit as z approaches c over z minus c, okay, z minus c times f of z. Okay, that is how we find the residue at c. Okay, so if f of z is undefined at this point, then it has a residue at that point, which is c, and we find that residue using this formula. The residue at c is given by the limit of z minus c times f of z as z approaches c. Okay. Then the integral at C and D, this is this, and the integral of f of z is equals to 2 pi I, the sum of residues, the residues of f of z. 2 pi I times sum of the residues of z from 1 to infinity. Okay, yeah, it has to be finite. So in this case, we're just doing from they have to be finite. So in this case, we're just doing from 1 to n. Okay, so this is the residue theorem. So basically, I think I've left out something. Let me see. If f of z is undefined at z naught is equals to c, then it has a residue at c this, then we just say where c is inside or on the boundary of tour z minus z naught is equals to r. So this is the residue theorem. Let me explain it simply. So if we have an integral and that integral is undefined at some point, z naught is equals to c, okay, then it has a residue at c, and we can find the residue at c by using this formula, limit z minus c, which is the point where the point where the function is defined, or the integral, times the function, which is this function that is here, which is usually the entire function. Then we replace in the function, what we have there is the residue at c. Then where c is inside the region of integration. So you will also be given a region of integration. So now this region of integration, c should be inside this region of integration, or it should be on the boundary of this region of integration. Okay, so let me just put a proposition here. So if c is not inside the region of integration z minus z naught is equals to r, if it is not on the boundary, then residue at c is equals to 0. Okay, so the things that you need here is that you need to check if the point where the function is undefined is inside the contour of integration. Okay, if it is inside, then we can go on and find the residue, or if it is inside or on the boundary, we can go on and find the residue. But if it is not inside, it is outside the region of integration, then the residue is 0. Okay, then this formula is what we use to compute the integral. Let's look at an example so that we better understand this. All right, so let's look at an example here. We want to evaluate the integral of 24 minus 2z dz divided by z minus 2. Okay, this is our f of z. This entire thing is our f of z. This is our region of integration. You are always going to have a region of integration for contour integration, right? So the first thing that you need is you need to sketch this region of integration. How you sketch this region of integration, you need two things only. You're going to need the center and the radius. The radius is this part here. The center will be gotten from inside here. So these are the two things that we need. So for the radius, how we got the radius, we just get what is here. So the radius is 2. The center, how we get the center, we look at the real number and the imaginary number. So in here, there will be a real number and an imaginary number. If we only have a real number, then the imaginary number is 0. So if we only have an imaginary number, then the real number is 0. And if we don't have we just have z, we don't have a real number or an imaginary number, then meaning that the center will be 0, comma 0. Okay, so again, for the real part, you always start with the real part. The real part, you get the positive, which is 2. Okay, if it is negative, you get the positive. If it is positive, you get negative. So like in this case, we see the imaginary part is positive 1. So the coefficient, we get the coefficient of I. We do not get I, we just get the coefficient of I. So in this case, it will be, the coefficient is positive 1. So the center now becomes negative 1. So now these are the two things that we need, the center and the radius. So we need to draw an XY plane. So just a quick sketch. So that is our XY plane. So this is, you need to draw the XY plane before these points, So these points will come on the XY plane. So you look for 2, comma negative 1, 2 will be here, comma negative 1 will be down there. So this will be the center. And we'll be moving 2 units down. So 2 units down. So it will just be 2 units down there. 2 units from this point, 2 units up, and 2 units, and so on and so forth. So now sketching that, so we get the center there. So it will usually be that time. So 2 units this direction, that will be 2 units from this point. That will be 1, 2. Or from here, we start from here, which is 1, 2. So it will pass on 4 here. From here, 1, 2 will be on 0. 2 units down, that will be 1, 2. So this is supposed to be 3 instead of it would be negative 3. This would be 1, 2. This would be 0, 1, 2. 2 units up, 1, 2 to be 1. So we've sketched our circle. So this is our first step. Step 1, sketch the region of integration. Okay, sketch the region of integration. Then after you sketch the region of integration, you determine whether, okay, you find the pole. How you find the pole is, or the point where it is undefined, okay, you equate the denominator to 0. So that is z minus 2 equals to 0. Then you solve for z. So z is equals to equals to 2. Okay, so now this should be either inside the circle or on the boundary. If it is outside, then we just say the integral or the residue is equal to 0. Okay, but if it is inside, now we can proceed to finding the residue at that point where the function is undefined. So to find the point where the function is undefined, we just get the denominator, we equate it to 0. That is where the function is defined. Okay, then we need to check, is this point inside or on the boundary or outside? If it is inside and on the boundary, we continue with our residue integration. If it is outside, we say the residue is equals to 0, the waste time. So now we check z is equals to 2 is inside here. So we've seen that it is inside the contour, so we can proceed to finding the residue at 2. So we are looking for the residue at 2. So we said to find the residue at 2, we take the limit as z approaches the residue, which is 2. Then here we say z minus 2. Then we multiply by the entire function inside the integral, which is 24. 24 minus is 24 minus, is it 2z? 24 minus 2z over z minus 24 minus 2z all over z minus 2. Okay, so that is our f of z from the residue theorem. Remember what we said in the residue theorem. If c is inside, c is a residue, or if f of z is undefined at c, then C as a residue. That is how we find the residue. We say Z minus the point where it is undefined, and limit as we approach the point where it is undefined, times f of z, which is the integral there. Then we said C should be inside. If C is outside, then the residue is 0. So in this case, it is inside. So we continue to finding residue. So further here, to find the residue, we'll say this is equals to 2. This will be equals to the limit as z approaches 2. We see that this and that cancel, then we remain with 24 minus 2z. Then where there is z, we replace 2 as we apply how we solve limits. So we replace 2 here, that would be 24 minus 2 times 2. Okay, so the residue at 2 will be 24 minus 4. So the residue at 2 is equal to 20. Okay, so remember the integral from 0, sorry. So the integral of f of z is equals to 2 pi I sum of the residue. Okay, and in this case, the residue is 20. So our integral, which is 24 minus 2z all over z minus 2 dz, 2 dz is equals to 2 pi I sum of residue. So in this case, it is just 2 pi I times, we only have one residue, which is 20. We had two residues, we add them. So the answer is finally, so this times that, it will be 40 pi I. So that is the answer. That is the answer for that one. So now I want you to try out this one. So we'll be waiting for your feedback. You evaluate integral of 4 2z all over z minus 1 z on the contour gamma, where gamma is contour z minus 1 equals to 1. So you sketch that. Then number 2, you are going to do it. So first try in this region, then secondly, the same question using the region z is equal to 2. Okay, so try out these two questions. So the first one is you evaluate in the region gamma, where gamma is z minus 1 is equal to that. Then number 2, gamma where, so here the center here is we only have a real part, so which is 1 comma 0. The radius is equals to 1. Here you figure out that. Then we do the same for 3. I'll give you do one more. 3, we have z minus I plus 1. So here the center will be, you remember, you try to figure out by yourself. So these are the activities for today. Do them, the activities. So you are using residue theorem. All right, so have a nice day. So wherever you have questions, you can ask us, able to attend to you. Have a good night.